Business Statistic for Data Science Capstone Project Hypertension, the vulnerable group because we care. Before we proceed to any further, we would like to introduce our group members. The first one from top left, Mini. The second one is Yan, and the one who eating kebab is Nadia, and the last one is Aman. So the outline of this video, the first one is going to be introduction, dataset information, objectives, tools used and data cleaning, descriptive analytics, statistical inference, predictive analytics, conclusions, and reference. What is hypertension? Hypertension, commonly known as high blood pressure. Blood vessels constantly raise pressure and higher risk of chronic disorder and death. As you can see here, based on World Health Organization's WHO, International Society of Hypertension, and death. As you can see here, based on World Health Organization's WHO, International Society of Hypertension, National Health and Mobility Survey says that hypertension is the #1 contributing risk for global death. Around 10 million people die each year needlessly. A blood pressure value of 140 per 90 mmHg is considered high. Worldwide, 1 in 3 adults has high blood pressure do not know that they have it. 99% of women have high blood pressure, lower than 32% of men. High blood pressure usually has no symptom. Age 18 and above have hypertension. Age 30 and above have hypertension as well. When blood pressure is high, 4 times die from stroke and 3 times die from the heart disease. There are 2 types of hypertension, primary and secondary. For primary, 90% to 95% of cases and 3 times die from the heart disease. There are 2 types of hypertension, primary and secondary. For primary, 90% to 95% of cases can affect anyone at any age. The secondary, hypertension caused by an identifiable source. For example, kidney disease, obesity, pregnancy, and etc. When you are having hypertension, it can lead you to stroke, loss of vision, kidney disease, bone loss, depression, anxiety, heart disease, sexual problem, and many more. What causes high blood pressure? The first is going to be smoking, lack of exercise, stress, too much salt, too much alcohol, older age, family history, and obese. Hypertension in Malaysia. As you can see here, there are many articles regarding hypertension in Malaysia. As you can see here, there are many articles regarding hypertension that happens in Malaysia. As you can see here, from January 24, 2018, which is the last year, Malaysians have a high score that dangerous for health. And as you can see, from back in 2016, 1 in 3 adult Malaysians have hypertension. So we can see that the source is from the STAR and NST. Information about dataset. We take dataset from 2015. As you can see here, there's a lot of information about our dataset, but we only choose state, citizenship, age, post-stratification rate, gender, average systolic reading, average diastolic reading, hypertension status, occupation, and total individual income to make our statistic better. Diastolic reading, hypertension status, occupation, and total individual income to make our statistic better. Objective: to explore the background of the sample of data by analyzing the descriptive statistic focusing on first, gender, second, age group, third, citizenship and state, fourth, occupation, and fifth, individual income group. Second, to examine the correlation between gender, age group, post-stratification weight with hypertension status. Third, to examine with the correlation between each average systolic of blood pressure with average systolic of blood pressure. Lastly, to predict suitable model for hypertension, average systolic of blood pressure by analyzing on each and average diastolic of blood pressure. Tool use. The first one going to be IBM SPSS. Second one is power of blood pressure. Tool use. First one going to be IBM SPSS. Second one is Power BI. The third one is going to be Excel. Data cleaning, a brief walkthrough. Original dataset has 90,936 instances. Data screening process is conducted to ensure the reliability of the data before further analysis. Data encountered to be missing or with the errors were removed. The first one will be variable occupation. Second one will be variable average systolic BP. And the third one will be variable total individual income. As you can see here, is the data area consists of 3,526. Final dataset that is ready for analysis has a total of 12,063 instances. Descriptive analytics. From this pie chart, we can see that they are descriptive analytics. From this pie chart, we can see that there are more males 59.37% than female 40.63% in this study. Majority of the age group of the sample in this study is between 25 to 29 years old and closely followed by 30 and 34 years old. A total of 2.6% of the sample is above 70 years old. As you can see, it's a bar chart here. The sample of data set represent our population estimate in Malaysia. Descriptive analytics. As you can see here from the bar chart, there are 12,603 Malaysian, having 50 states and federal territories. And it shows that Selangor, Johor and Sabah and Wilayah Persekutuan Labuan having their highest state for territories. And it shows that Selangor, Johor and Sabah and Wilayah Persekutuan Labuan having their highest state for descriptive analytics. Most of the sample work in the private sector. 45.3% equals to 5,712 employees, followed by 28.7% equals to 3,612 self-employed, and 16.8% equals to 2,123 employees working in the government and semi-government sector. As you can see here, there's a private employee, self-employed, government and semi-government, retired, unpaid worker, students, and this is it, the result. Descriptive analytics continue. Majority earns less than 1,000, 36.0% equals to 4,537, followed by 26% equals to 3,271 between 1,000 to 1,999, and 15.6% earns between 2,000 to 2,999 equals to 1,963 sample. Only 10.9% equals to 112 earns between 8,000 to 9,999 ringgit. Statistical inferences. Independent variable gonna be gender, and dependent variable is hypertension status. From the cross-tabulation graph, a total of 4,222 samples can be found to have hypertension. Meanwhile, from the cross-tabulation graph, a total of 4,222 samples can be found to have hypertension. Meanwhile, 5,581 of the samples do not have hypertension. Out of 4,022, it can be found that 62.46% males equals to 2,512 have hypertension compared to females, which is 37.44%, which is 1,510. Independent variable continued. From this cross-tabulation graph, a total of 4,202 samples can be found to have hypertension. Meanwhile, 8,581 of the samples do not have hypertension. Out of 4,222, which is 16.3%, is from age group 50 to 54, which is 654, followed by 30.5%, which is 543, between 45 to 49 years old. 12.7% equals to 512 between samples between 55 to 59 years old, and 427 which is 10.6% between 4 to 44 years old have hypertension. Sample age is between 15 to 16 years old has the least number of hypertension cases with the number sample 31, 0.8%, followed by 1.9%. 16 years old has the least number of hypertension cases with the number sample 31, 0.8%, followed by 1.9%, with 75% samples with age more than 75 years old. Statistical inference. Independent variable is going to be post-stratification weight, and dependent variable is hypertension status. So post-stratification weight and having hypertension status no and yes. From this group statistic table above, it can be found that the mean for the sample with hypertension is 916.0707 with standard deviation of 816.16495. Meanwhile, mean for sample with a hypertension is 1132.4981, standard deviation 919.48144. Next. Based from the Leibniz test for equality of variances, table above, in a condition of equal variances not assumed, it can be found that the p-value is less than 0.005. It can be concluded that there is statistically significant difference between the mean of hypertension status, yes and no. Independent variable age and average systolic of blood pressure, dependent variable average systolic of blood pressure. Based from person correlation table and scatter plot, average systolic of blood pressure is highly correlated with average systolic of blood pressure with correlation coefficient of 0.722. Meanwhile, correlation with age is medium with correlation coefficient of 0.412. Here is the calculation for average systolic BP and age. Predictive analytics. In this study, we would like to predict suitable model for hypertension by measuring the dependent variable Y, average systolic of blood pressure, independent variable, average systolic of blood pressure, X1 and X2. As you can see from formula here, where E equals to 0, the R square value represents the goodness of fit measure of linear regression. Based on the table above, it can be found that the value of R square is 0.5690, which means that 59% of the variance in the average systolic of blood pressure is influenced by the average systolic of blood pressure and the age variables. From the A and OVA table above, the p-value is less than 0.005, which means that the model with the average systolic of blood pressure and the age as predictors, independent variables and average systolic of blood pressure as dependent variable is significant with F2.12600 equals to 9081.8952. The model is a good fit for this data. From this table above, the p-value is less 0.005, which means that the model with the age and average systolic of blood pressure as predictors, independent variables and average systolic of blood pressure as dependent variable is statistically significant. The predictive model is as below. Y equals to 28.888 plus 1.083 average systolic of blood pressure plus 0.344H plus error. Summary of findings. Research objective: to examine the correlation between gender, age group, post-infection weight with hypertension status. Hypothesis: there is a correlation gender, age group, post-infection weight with hypertension status. P-value is null. Finding is null. To examine the correlation between age, average systolic of blood pressure with average systolic of blood pressure. There is a correlation between age, average systolic of blood pressure with average systolic of blood pressure. The p-value is 0.05 is greater than 0.00, and for the finding is supported. To predict suitable model for hypertension, average systolic of blood pressure by analyzing on age and average systolic of blood pressure. The hypothesis: there's a fit model for hypertension, average systolic of blood pressure with age and average systolic of pressure as independent variables. So the p-value is going to be 0.005 is greater then 0.00, and it is supported by each and every decile of pressure as independent variables. So the p-value is going to be 0.005 is greater than 0.00. For as a conclusion, age plays a vital role in hypertension. Decreased performance in cardiovascular system, decreased kidney function, ability of the body process the result, lesser fluid in the bloodstream as the blood volume changes, reduced elasticity of the blood vessel, degeneration of the heart muscle cells and thicker cell wall, higher tendency of fat deposit in the heart's pacemaker system. Hypertension more prevalent in Malaysia. Age plays a vital role. A fit model obtained for hypertension, future research on the other variables such as race, marital status and lifestyle habits. Everyone can take 5 concrete steps to help prevent high blood pressure. First one, give me a healthy diet, physical activity, avoiding tobacco, avoiding harmful use of alcohol and managing stress in a healthy way. References, as you can see there's 7 references and you can take a look at them. Avoiding tobacco, avoiding harmful use of alcohol and managing stress in a healthy way. References, as you can see that's all from us. Thank you.